Okay, I'm now working the homework for 10.2, which is the section on vectors. And I'm going to start with number 2. I hope that I'm able to draw this okay. All right, so first they give you this diagram. And calls A, B, C, and D. And they want us to, for number 2, part A, look at A, the vector from A to B, plus the vector from B to C. And they want us to express that as a single vector. So the vector from A to B is this vector here from A to B. Okay, that would be this one. I'll do that in red. That's your vector AB. Then the vector from B to C, the vector that goes from B to C is here. So when you add two vectors together, you start from the tail of the first vector and you place it upon, you take your first vector, you take its tip, you attach it to the tail of the second vector, which is here. So tip to tail, and then you'd result here. So we're going to wind up going from this point to this point. So really, if we look at this vector that goes from A to C, that is equivalent to going from A to B and then B to C. So this would be equal to the vector AC. So let's try and do, I think I'll do part B, and then I'll let you, no, I'll do C. C is a subtraction. So dB, the vector from D to B, minus the vector from A to B. So get rid of this one and this one. Okay. The vector that goes from D to B, which is this one, subtract the vector that goes from A to B. So remember that subtraction, right? So when you subtract AB, that's the same as the vector B to A. So it's the vector that's pointed in the opposite direction. If you go, instead of going from A to B, you go from B to A. That's what it means to subtract it. So what I need to do is, if this is the vector from A to B, we want to go backwards, then you're actually going here, like this. So this is the vector negative AB, which is also the vector from B to A. So you're attaching the tip of this one to the tail of this one. And what winds up happening is you result here. So you start here, go up, go over, and you're there. So the vector that goes from D to A is actually equivalent to this. So D to A. All right, I'll let you do B and D yourself. That's number 2. Number 4 is next. Copy the vectors in the figure and use them to draw the following vectors. So they give you a vector drawing here. Call that the vector B. Call this the vector A. Part A, they want A plus B. Well, all you have to do there is take the tip of A and attach the tail of B to it. So I want to take this vector, okay, take its tail, slide it over here, and attach it to the tip of A. So there's B moved over. So you start here, you go A, you add B, you result there. So the resultant vector is this drawing right here. That is the vector A plus B. So that's part A. Let me do part F. I'll let you do all the others. F is 2B minus A. So I'll start with a new drawing. All right. So first of all, what is 2B? Well, here's B. Twice B, all it does is doubles its length. So there's 2B. And then what I want to do is I want to subtract A, which is the same as adding negative A. So if this is A, negative A is pointed in the opposite direction, same length. And then what I'm going to do is attach the tail of this to the tip of this one. So I'm going to slide that up like that. That's, sorry, that's negative A. I forgot to put negative A. And so the result, when it's all said and done, is this vector right here. You start here, you end up here. That is 2B minus A. This one right here. All right, let's move on to number 5. Number 5, find the vector A with the representation given by the directed line segment AB. Draw AB, start at the origin. So for 5, they give you point A is the point negative 1, 1. Point B is the point 3, 2. And so we want to try and find this vector A, which is the vector that goes from A to B. So this is two-dimensional, so this should be pretty easy to draw. Negative 1, 1 is point A. 3, 2 is point B. So the vector from A to B goes like this, and we'll call that little a. Then what they want you to do is they want you to draw it again, but reorient everything so that it's moved to the origin. So basically I'm going to move this point down 1 over 1, this point down 1 over 1, and that way that's an equivalent representation of the vector A. It's just been translated over. So remember, as long as it has the same length and same direction, it's equivalent. So they just wanted you to move it to the origin. Now let's try something like, that was number 5. Number 8. You have 2 points again. Now we're in 3-dimensional space, so this is going to be a little bit harder to draw. But I think we can do it. Am I recording? Okay, good. 4, 2, 1. All right, so here we go. 3D. 4, 0, negative 2 is A. So 1, 2, 3, 4. Don't move anywhere on the Y. Down 2. Okay, there's A. And then B is 4. And then 2 to the right, up 1, which is here. It's B. So out 4, to the right 2, up 1. And then it's the vector from A to B, which is this. And, oh, you know what? I forgot on the last problem, darn it. It's okay. On the last problem, I'll do it real quick. We had the point negative 1, 1. We had the point, darn it, I forgot to actually get the vector. I drew it, but I didn't get it. Vector A is going to be angled bracket, since we're going from A to B, we take b, the first coordinate of b, and we subtract this. So 3 minus negative 1 is 4. And then here, 2 take away 1 is 1. So if you go back and look at that picture we drew, if you start at the origin, go out 1, 2, 3, 4, and go up 1, that should have been the a that we had when we moved it to the origin. Sorry about that. Okay, over here, a. Again, we're going from a to b. So we'll go this minus this, this minus this, this minus this. So we get 0, 2, 3. Angle bracket. So if I were to start at the origin and I don't go anywhere on the x-axis, I go to the right 2 and up 3, right? 1, 2, 3. Draw. These two vectors should have the same length and same direction. So that's A. That's A. Okay. What's next? Number 11. Find the sum of the two vectors and illustrate it geometrically. So we have two vectors here. Did I skip 9? No, I didn't assign 9. So we have two vectors, 3, 0, 1. And we have the vector 0, 8, 0. I want to add these, find the sum, and illustrate it geometrically. So let me add the two vectors together. Adding these two vectors together is pretty easy. You just do the components. So 3, 8, 1. Now I want to show that geometrically. So 3 on the x-axis. So 1, 2, 3, 8 on the y. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to come out parallel, parallel, some around here, and then up 1. So from the origin to there is the sum of those two vectors. So it came up 1. You can kind of start to get good at, you know, kind of throwing other stuff in there to kind of help you see where things are. And that kind of shows you, I hope that kind of shows you you're in the first octant there. 13, find, there's a couple things on 13 you're supposed to find, so. For 13, you know, I think I'll skip 13, I'm gonna do 15 instead because 15 is harder than 13. So for 15, they give you A is equal to, excuse me, A is equal to I plus 2J minus 3K. B, the vector B is equal to negative 2I minus J plus 5K. And the first thing I want to do is find A plus B. Then I want to find 2A plus 3B. And then I want to find the magnitude of A, and then the magnitude of A minus B. So first, let's just rewrite these in different notation. This is the same as the vector 1, 2, negative 3. That's what the ijk means. Then here, negative 2, negative 1, 5. All right, let's add the two together first. When we add the two together, we get a new vector, just adding the components of the vector. So negative 1, positive 1, 2. Now, if we do 2 times A, scalar multiplication, plus 3 times B, another scalar multiplication, then we should get 2 times A. So let's just double this vector. So that's the vector 2, 4, negative 6. I'm going to add to that 3 times B, so I multiply everything by 3, negative 6, negative 3, 15. And then when you add those two together, you do components. So 2 and negative 6 is negative 4. And then 4 and negative 3 is 1. Negative 6 and 15 is 9. All right, let's do the magnitude of A. Magnitude of A is the square root, it's the length of A, is the square root of each of the components squared. So 1 squared, the sum of the components squared. 2 squared plus negative 3 squared, which is, let's see, square root 1 plus 4 plus 9, which is root 14. And then A minus B, the length of it. So let's figure out what the length of, well, let's figure out what A minus B is first. A minus B is this vector, take away this vector. So you're going to do this component minus that component, this component minus that component, this component minus that component. So 1 take away negative 2 is trying to find the magnitude of the vector 3. 2 take away negative 1 is 3. Negative 3 take away 5 is negative 8. Check this. Okay. Now, the magnitude is the square root of each of the components squared. So 3 squared is 9, 3 squared is 9, 8 squared is 64. So what do we have there? That's 82, root 82 is the length of that vector. All right. That's number 15. Let's look at 17. 17. We want to find a unit vector with the same direction as the vector 8i minus j plus 4k. We need to find a unit vector in the same direction. So remember that given a vector, a non-zero vector, we can always find a vector that's pointed in the same direction but has a length of 1. And to do that, we can convert this over to the angled brackets first. Okay? What we need to do is find the length of this. Okay, so the length of that vector is the square root of each of the components squared. So 64 plus that squared is 1, plus that squared is 16. So 65 plus 16 is 81, right? My math, I just can't do it today. Square root of 81 is 9. 65, 75, 81. Okay, 9. So all we do now is we take this vector and we divide each component by this length. So 8 over 9, negative 1 over 9, 4 over 9. That vector will point in the same direction as that and have a unit length. Remember, all we did was we scaled this. We took this and we scaled it, multiply it by the number 1/9, passed it through. So it should point in the same direction, just should shorten it. And the length of that should be 1. Should we check it? Yeah, let's check it real quick. Is the length of this 1? 1? Is that 1? So if I asked you to find the length of that, you would say, what's the square root of each component squared? So 64 over 81 plus, let's see, that's going to be 1 over 81 plus, let's see, 16 over 81. And all have the same denominator, put them together. The numerators add up to be 81. So you get root 81 over 81, which is 1. So it does work. 17, see 19. What is the angle between the given vector and the positive direction of the x-axis? So they give you a vector. The vector is I plus root 3j hat. I haven't been saying I hat, j hat, k hat, but I'm writing it down, so I hope you understand that. This is a two-dimensional vector. That's where it is. And we're trying to find the angle between that vector and the positive part of the x-axis. So if I were to draw this vector, I go out 1, I go up the square root of 3, and that would be an equivalent displacement vector right there. That's equivalent to that vector. You could slide it around anywhere. I'm just trying to find this angle here, which I'll call theta. Well, I could form a right triangle out of this. This is root 3, this is 1. And then I could do something like this. I know that tangent theta is opposite over adjacent, so is root 3. So that means that theta is arctangent of root 3. So whatever that is. And is that a common angle? Well, go back to your unit circle. Right, this is like pre-calc, so we're going pretty far back. There are some common angles here. The one here, these have the coordinates root 3 over 2, 1/2. That was pi over 6. Pi over 3 up here was the other way, 1/2 root 3 over 2. If I were to take this, the opposite, or the y coordinate divided by the x coordinate, that's what tangent is, would I get root 3 in either of these cases? So notice that if I take this one, I take the y coordinate, root 3 over 2, and I divide it by the x coordinate, that's what tangent is, that the 2's would cancel. You just get root 3. Now if you do it the other way around on this one, it won't work. You'll get 1 over root 3. So the angle that we want here is pi over 6. Sorry, pi over 3. Okay, that comes from here, that angle. Yes, you could get your calculator out and do that, but it's Cal 3. We should know how to get that by now. What's next? 1921. A quarterback throws a football, angle of elevation is 40 degrees, speed of 60 feet per second. (40 degrees), speed is 60 feet per second. So we're going to say that this right here, this is the ball. It's moving 60 feet per second in that direction. So here's where he threw it from. There's the angle. And what they want to know is find the horizontal and vertical components of the vector velocity. So they're saying if you were to break this vector down into two components, this vector and then this vector at right angles to each other, what would the horizontal vector look like and what would that one look like? So what are the components? So what I'm going to do is I'm going to actually figure out what this black vector is in its component form. All right, so to do that, I can use just some basic trigonometry. And I can figure out that if this were a right triangle, if I wanted to know, let's call this side, let's call it H for horizontal, and then we'll call this V for vertical. I know that sine, what should we do first? Let's do H. Cosine of 40 degrees should equal H over 60. And that means 60 cosine of 40 degrees should be H. And then I can do the same thing to get V. I know that sine of 40 degrees should be opposite V over hypotenuse 60. And then multiply both sides by 60. 60 sine of 40 degrees is V. So this right here, okay, this piece right here is H and V. And the H would be the horizontal component of the vector and the V would be the vertical. So I don't have my calculator, but you could go figure out what this is, and that you would get both your H and V. You'd be done. All right, what's next? 23. Did I do the wrong one? Crap. I did 23. I was supposed to do 24. Damn it. Oh well. All right, 24. Find the magnitude and resultant force in the angle it makes with the positive x-axis. So you have number 24, I should write this down. You have a vector 45 degrees pulling 20 pounds, 45 degrees here, and then 30 degrees vector pulling 16 pounds. So the length of the vector corresponds to the pounds corresponds to the length of the vector. So we're saying that that's 16. We're saying the 20 pounds that this is 20, so it's longer than this one. This one is 30 degrees between here and here. This one's 45 degrees. So it's like if you were pulling on a point, 20 pounds of force this way at 45 degrees and 16 pounds of force 30 degrees, what would the result be? So we want to find the resultant vector. So what we could do is we could use the parallelogram law to draw it. If we take this vector and just slide it down, it should be something like that. Or if we were to take this vector and slide it up, it'd be like that. So the resultant vector of those two together should be this vector. And we're trying to find out how long this vector is and the angle that the red one is making. So what would really help me here is to convert these two vectors into their component forms. So I'm going to call this vector A, this vector B. I would like to get A written as its component, so I'll call it A1, A2. And then B, I'm going to write B in it. I need that in its component form. If I can do that, then the red vector, okay, is going to be A plus B. Right, this vector right here is A plus B. And it'll be very easy to add these two together if I know what these two pieces are. So let's go and just draw this again. Let's work with just A first. I know that this is 20. I can draw a right triangle. This is 45. So I could do the same exact thing I did in the previous problem. I could find the horizontal component and the vertical component, which actually I'm calling B1 and B2, or A1 and A2. So this is A1, this is A2. And then use your sine and cosine stuff. So cosine of 45 degrees equals A1 over 20. Cosine of 45 degrees, so I'm multiplying both sides by 20. Cosine of 45 degrees is root 2 over 2, is A1. So this is 10 root 2. And then you can go through and find A2 the same exact way, and since it's 45 degrees, you're going to find that A2 is the same. Okay, so you've got A1 and A2. Now let's do the B picture. The B is 30 degrees here, and we want to find B1 and B2. We have to be careful though, because this angle is a little deceiving. 30 degrees this way really corresponds to 330 degrees this way. So we could set this up the same way. We know that cosine of 330 degrees is equal to B1 over, how long was this one, 16? And we know that sine of 330 degrees is equal to B2 over 16. And what is cosine of 330? So cosine of 330 should be root 3 over 2. So this one becomes, and I'll multiply both sides by 16. 16 times root 3 over 2 equals B1. And then sine of 330 is actually going to be negative 1/2. So 16 times negative 1/2 equals B2. And so B1 is 8 root 3. B2 is just negative 8. And so we have these two vectors. So let's put them together. All right. A1 was 10 root 2, 10 root 2. B1, B2 was 8 root 3, negative 8. And now let's add the two vectors together. So if we add them together, a plus b, we get 10 root 2 plus 8 root 3. Can't really put those together. Then 10 root 2 minus 8. Okay, that's a plus b. We need to find its length to figure out how long this is. So the magnitude, a plus b, equals, and we're going to have to do some square roots in here and squaring, and it's going to be a mess. I'm wondering on 20, well, I wonder if they have, if they want this in decimals. I guess we could go to decimals at this point. So get on your calculator, figure out what that number is, figure out what that number is. And once you figure that out, you know, you go in here and you take this number, you square it, plus this number, you square it. I mean, you could do this by hand. I don't feel like doing it. You're multiplying two terms, but they involve roots, and it's just algebraically, I don't have time for it. So figure out what that number is with the calculator, put it here, square it. That number on the calculator, square it. Put that all together, square root. That's the length, and that should represent this. And then to find the angle, right? To find the angle, I'll draw the picture so you can see it. To find the angle of this, you actually know, you're trying to find this angle, I'll call it theta. You actually know the height here. It's this right here, 10 root 2 over minus 8. And you know this length right here, which is 10 root 2 plus 8 root 3. So if you want, get that on a calculator with a decimal, this decimal here, and then just do arctangent in order to figure out what that angle is. All right, that's it for 24. 26, I'm gonna let you do 26. Only because there's one like that on on one of my take-home exams for my face-to-face class, and I don't want to give it away. So I think what I did there is sufficient for you to get you through the main concepts here of 10.2.